Have you ever pondered the fluidity of time and the vastness of space? These are not mere musings of a wandering mind, but the very essence of our universe, intriguingly intertwined. Today, we are going to delve into two captivating concepts that stretch our comprehension of this reality: time dilation and warp drives. These aren't just figments of science fiction, but concepts that have been pored over and theorized by some of the most brilliant minds in history. Albert Einstein, with his groundbreaking theories of relativity, introduced us to the idea of time dilation, the notion that time can stretch and shrink depending on speed and gravity. Carl Sagan, the renowned astrophysicist and cosmologist, explored the concept of warp drives, which theoretically could allow for faster-than-light travel by bending the fabric of space itself. So, prepare to have your mind stretched as we dive into the fascinating world of time dilation and warp drives. Imagine a clock that ticks slower the faster it moves. Sounds absurd, right? But that's exactly what happens, according to Einstein's theory of relativity. This phenomenon is known as time dilation, and it's one of the most fascinating aspects of our universe. So, let's break this down. Picture yourself on a train, not just any train, but a super-fast intergalactic space train that can travel close to the speed of light. Now, on this train, you have a clock. To you, this clock ticks normally, just like any other clock. But for someone observing from a stationary point, like a platform, the clock on your train is ticking slower. The faster your train moves, the slower your clock ticks, in the eyes of the observer. This is the essence of time dilation. As you approach the speed of light, time appears to slow down. This doesn't just apply to clocks, but to everything. Your heartbeat, your thoughts, your very existence would seem to be in slow motion to someone observing you. This is not some abstract theory, but a reality proven by countless experiments. Even GPS satellites have to account for time dilation. They move fast enough and are far enough from Earth's gravity to experience time slightly slower than we do on Earth. If we didn't correct for this, GPS would be off by miles. Time dilation isn't just a quirk of the universe, but a fundamental aspect of our reality. It challenges our perception of time as a constant, unchanging entity. Time, it seems, is as flexible as a rubber band, stretching and contracting based on speed and gravity. Now, I know what you're thinking. This sounds like something straight out of a science fiction novel, but the fact is, time dilation is a very real phenomenon, verified by some of the most brilliant minds in physics. So as you speed up, your clock slows down. A mind-boggling concept, isn't it? But that's the beauty of science. It constantly pushes the boundaries of our understanding, opening up new realms of knowledge and challenging our perceptions of reality. Now imagine folding space like a piece of paper. Sounds even more absurd, doesn't it? This is essentially the concept behind warp drives. It's a theory that proposes a method of faster-than-light travel by bending or warping the fabric of space-time. To understand this, let's pretend we're ants on a string. If we're walking from one end to the other, it would take quite some time. But what if we could fold that string so the two ends meet? Suddenly, our journey becomes a lot shorter. This is the principle warp drives operate on. They wouldn't push us faster than light, but instead, they'd shrink the universe around us. Hard to wrap your head around? That's okay. It's a concept that's been puzzling scientists for decades. The term warp drive itself was popularized by science fiction, particularly Star Trek, but the theory behind it is based on real science. It's rooted in Einstein's theory of general relativity, which tells us that space and time are intertwined in a four-dimensional fabric known as space-time. So how does this work? Well, a warp drive would create a bubble of flat space-time around a spaceship. Behind the ship, space-time would expand, pushing it forward, while in front of the ship, space-time would contract, pulling it forward. This bubble would be surfing on a wave of space-time, effectively shortening the distance between 2 points and allowing the ship inside the bubble to reach its destination faster. It's an enticing idea, isn't it? To traverse the cosmos in the blink of an eye, to reach distant stars and galaxies that would otherwise remain forever out of our reach. But remember, this is all theoretical. As of now, we don't have the technology or understanding to manipulate space-time on such a grand scale. So, in theory, we could zip across the universe in no time, if we could manipulate space-time itself. Now, what happens when we combine these two seemingly absurd concepts, you might ask? Well, let's dive into the interplay between time dilation and warp drives to find out. Imagine you're on a spaceship equipped with a warp drive. You fire it up and start traveling at warp speed. What does this mean for time dilation? In essence, the faster you go, the slower time moves relative to an observer at rest. This is the core principle of time dilation as put forth by Albert Einstein in his theory of special relativity. So, as you zip through the cosmos at warp speed, time on your spaceship would slow down significantly compared to time back on Earth. It's a real mind-bender, isn't it? The universe doesn't care about your schedule, it has its own rhythm. Now, let's take it a step further. What if you traveled to a distant star? Let's say it's 4 light years away. To the folks back on Earth, it would take you 4 years to get there, even traveling at the speed of light. But remember, you're not just traveling at the speed of light, you're traveling at warp speed, which is theoretically faster than light. To you, on your warp speed spaceship, the journey might feel like mere minutes. But what about those left behind on Earth? Due to the extreme time dilation caused by your warp speed journey, while you've been sipping space coffee and enjoying the cosmic view for what felt like a short while, centuries could have passed by on Earth. In essence, while warp drives may allow us to traverse vast distances in the blink of an eye, they could also drastically stretch the fabric of time. It's a double-edged sword of cosmic proportions. So a trip to a distant star might feel like mere minutes to you, but centuries could pass by on Earth. It makes you wonder, doesn't it? Would we still yearn for the stars if we knew the cost? Only time, it seems, will tell. Sounds like something straight out of a sci-fi movie, doesn't it? But how close are we to this reality? In truth, the concepts of time dilation and warp drives are not just the stuff of science fiction. They are real phenomena, grounded in the laws of physics as we understand them today, and they have serious implications for our understanding of reality. Our current scientific understanding of these phenomena is at the exciting cutting edge of research. Time dilation, for instance, has been experimentally confirmed. With the advent of precise atomic clocks, scientists have been able to measure the minuscule time dilation effects that occur even within the gravitational field of Earth. Astronauts returning from space missions are, technically speaking, a tiny bit younger than their counterparts who remained on Earth. Yet, experiencing time dilation to the dramatic extent portrayed in movies, where years pass on Earth while only hours pass for the traveler, is beyond our current technological capabilities. As for warp drives, the idea of bending or warping space-time to achieve faster-than-light travel is fascinating. But here we encounter a formidable obstacle: the immense energy requirements. Theoretical physicist Miguel Alcubierre, who first proposed the concept of a warp drive, calculated that to warp space-time enough to travel just a few light years would require energy equivalent to the mass of Jupiter. For reference, that's more than 300 times the mass of Earth. Moreover, even if we had access to such vast amounts of energy, we currently have no known way to manipulate space-time on such a grand scale. Theoretical physics suggests it might be possible, but it's a far cry from a practical blueprint for a warp drive engine. While we're not quite ready to hop on a warp drive spaceship, these concepts continue to push the boundaries of our understanding of reality. They challenge us to reconsider our notions of time, space, and the very fabric of the universe. And who knows, with enough time and a few scientific breakthroughs, we might yet see some of these ideas become reality. So we've taken a whirlwind tour of time dilation and warp drives. But what does this all mean for us? We've journeyed through the stretching of seconds, the theory of time dilation, and how gravity and velocity can impact the flow of time. We've ventured into the realm of warp drives, bending the universe to our will, and how this technology could potentially make interstellar travel a reality. We've explored the interplay between time dilation and warp drives, how these two concepts intertwine and shape our understanding of reality. We've delved into the current reality of these theories and the practical challenges we face in bringing them to life. This exploration is far from over. As we delve deeper into the mysteries of the universe, we continue to push the boundaries of our knowledge and understanding. The dance of time and space is a dance of discovery, a dance of exploration. As we continue to unravel the mysteries of time and space, who knows what fascinating discoveries await us on this cosmic dance floor.